Breezy day, blustery. Thanks for being in the middle of my shot that I'm trying to do right now.
Sorry.
Thank you. Breezy, a little rainy, but we're here at CBC talking to the MagTech folks. It's gonna be an awesome day. I'm super excited. Today's video is brought to us by MagTech Ammunition. Whether I'm shooting rifle or pistol, if I'm on the range training, MagTech Ammunition is along for the ride. Hey everybody, this is Reinaldo with CBC, and he's gonna walk us through the manufacture of 7.62 that we do here on site.
And 5.56 airsoft, convertible line.
5.56, so talk me through the process here.
Yeah, we have the whole process of manufacturing of cartridge 5.56, 7.62, 300 blackout in just one build. It's a very short lead time inside our operations necessary to produce our cartridge, starting for the coil to the complete assembled cartridge in the other point of the building. Yeah, let's go.
Let's go see it. So we start with extruded copper, right?
Yeah, we start with the coil.
Coil copper.
Coil copper. After that, we press in the double stroke press, and then we have the case, the cup for the case. And after cup of the case done, we have the drawing process. And drawing process, we have 3 drawing process in just one machine. That after this 3 drawing process, we have some annealing process in order to make the surface, especially the raw material, available to be tapered, and then goes to a progressive press to be tapered. And then on this progressive press, we have tapering, primer pocket, flash hole, marking in just one machine. And then we have a lot of operations in just one machine.
Yep.
And then we have the case, the brass is already done. Able to be just to put to be turned, and then we do grooving and cutting to length. After that, we go to annealing, mouth annealing process, and then put primer, loading, and done. We have the cartridge done.
But not only that, we've already built the projectile as well.
Yeah,
we've taken
sure.
the lead and the copper and built a projectile from
Yes,
scratch.
yes.
From blocks of lead
Yes.
and copper.
This we have in our components factories that is spread around the assembly factory. This is assembly factory. We receive hour by hour, 1 hour enough of the amount of production for components in order to be assembled there. For example, we have 1 hour of primer that is coming for the primer factory, delivered 1 hour by hour on the assembly
Primers
lines.
they've made on site.
Yes, everything made out here inside. And we have also 1 hour of bullets delivered to be assembled on loading machine. It's the same. The cups for this line is produced inside, and then we put together in just one building the complete cartridge for 5.56 or 7.62.
So this is a really cool process, you guys. I'm going to let you in to see that. It might be a little loud for us to get audio in there, but let's go take a look. So this is where it all starts. This is the copper coil, right? So this is going to become.
This is the coil. Yeah, the raw material is brass. Brass is 30% zinc, 70% copper.
And you can see them right over here, and they're putting that on the wire and sends it in to start making casing. I mean, I gotta be honest, I've never thought really about the fact that this is where my ammo started, you know?
Yeah.
I just load a magazine of 5.56 and go to work, but it started here on a coil. It's pretty cool. And this is stamping out raw, the cups.
You know, it's just 2 hours of production.
It's
Just very fast, very
2 hours
fast.
of production. Wow. Yep, making cups.
So, then after that, we press, we have here our cleaning process, annealing process, then we put,
Annealing and washing.
yes, we do annealing process there and washing again. And then wash, annealing, and washing again, and then our material is ready.
And although, let me see if I understand this right. Annealing kind of relaxes the metal so that it can be necked and all that, right?
Yeah.
It's exactly, so that's what annealing does.
It's in a furnace. It's about 680 degrees, Celsius degrees.
So it takes the metal that it's been put in a spot and makes that its natural place.
Yes.
Ah, I remember.
Here.
This is what the cups look like.
Before
Oh, here we go.
and after.
So that's how it comes out. And that is going to become a cartridge.
Yes, ready to be drawn.
Yeah, case. Very cool.
So, here we have the drawing process.
So now it's being drawn.
On this process, we have the three-phase case. We have first round, second round, third round. Then we have the case complete drawn. Okay, just one press.
Like in one press.
Let me show you. This is the drawing working.
So this is that press working.
From this to this.
That's taking this, turning it into this. Three different presses. All at the same place. That's really cool. So
Tapering.
Tapering.
We have here tapering, binder pocket, threshold, marking, and hedging. Everything just one press, one process. And the case is already part already done. Yeah? Now,
So this kit, it creates the case head, primer pocket, stamps it, and tapes it.
yes,
In one machine. Pretty awesome.
progressive press.
So you'll notice we're pulling stuff out and we're not putting it back because we don't want to put our hand oils in the machine.
Yes,
We'll take them and not put them back.
okay.
They're contaminated.
After taping, we groove and cut to length. Then we do grooving and cut to length in just one machine also. A CNC turning machine has a controller, a lot of electronic inside. Just for grooving and cutting to length. So, and then quality control. We control.
Quality control.
A laser machine without contact is able to control every dimension in order to guarantee the quality of the case. We have the profile and we compare the profile to our standard by using laser device.
John, come in and show it this way. So it's using the camera to inspect every single one that comes through, approving these ones. These are the ones that it says no for whatever reason. It's not meeting specs. These are going to go to a human to look over and fix.
Then we have the mouth annealing. The case will be ready to put the bullet. But prior to do that, we must hit the mouth.
Heat treat it
Yes,
so that it doesn't crack when you open it up by
to
putting
avoid
it in.
crack and so on. Because inside we have a pressure here after putting the bullet. Here's what it seems like.
So if you notice, you can see that it's slightly discolored up in the top. And the reason it's slightly discolored is they've annealed it. So they put it under the heat. So then that way it's taken a set here. So then that way when you stretch it a little bit and you put the projectile in, it doesn't crack. Because it's able to maintain its elasticity. That's what annealing does.
Yes, to stabilize the raw material in order to avoid crack after putting the bullet.
My physics and chemistry in high school are paying off. All that engineering time in college.
This way. Walito.
We're getting Joe.
Bill,
I feel like it's hit again.
parte uma máquina de colete.
Now this is a cool machine. This is what's priming.
Yeah, put the primer.
We're putting primers in.
Yeah, here is primer machine. Here we put the primer by starting here. The primer, last one to put. He's putting his primer now. The primer comes from inside. We separate and put in this safety device. In this feeding, we deliver the primer to the assembly plate.
And again, those primers just got delivered here an hour ago.
Yeah. How much?
An hour or two ago?
An hour is about 6 por hora. So the best canais, eh? 2 channels, 12,000 hours.
This is not like your Dylan 550 at home, kids.
12,000 hours. So you can see 2 plates with camera, jack for quality control in order to guarantee the correct position and insertion of the primer.
It's amazing how fast I can put primers in those things.
Yeah, very fast. Wait. Then we show you the another varnishing, another varnishing machine because this is not working, okay? I'll show you that. But before, should be great if a loading machine running, okay? There, it's the same machine, okay?
Okay.
Tá ligado? It's coming. Perfect, ligado. Perfect.
Okay, so now we're in, that's a multi-stage loader.
Yes. Then we have here cage feeding, bulk feeding, gunpowder feeding. We put together and we control a lot of parameters in order to guarantee the quality. For example, gunpowder level, if the gunpowder is not in the correct level, then discharge.
Then it dumps it.
Yes. And then we have a length control. We control the length. If it's not correct, the same. And shape control. We have a chamber that simulates the chamber of the weapon. Exactly like.
Chamber check.
Yes, the chamber. The same. And then we can separate what is not on shape, okay? And after that, we have in the end of the line here, the assembly load at 556. Right.
All ready to make pew-pew noises.
Yes. So, okay?
Yeah.
We can go to varnishing also. So that's okay.
Look at the varnishing.
Varnishing here, sealing, sealant. So
this one's interesting because a lot of people, they look at that varnish and they go, oh, I want to see this big varnish, but that's not how we do it anymore.
yeah, we need to do that in order to become waterproof the ammunition. In the past, we just used bitumen in order to guarantee this. Nowadays, we have a lot of new technology. For example, this is a very special fluid that do the sealant of the chip and the sealant of the primer pocket here, yeah, in order to become waterproof. How? By using a piezoelectric device that atomizes the fluid inside the channel here between the bullet and the case and inside the primer pocket. After that, it goes to a UV curing system that is able to cure in about 5 seconds. And then we have the ammunition waterproof.
Well, and again, another quality control check, right? Another check that says, nope, this didn't meet the standard. So you see it's all off a little bit, they say no, and then they'll have either a human fix that or they'll start it over.
But yeah, right. You have a camera that is checking if the application is correct. UV reaction camera. And this camera will check if the application was correct or not. The camera just detects the UV and compare with the standard
rod here,
UV
it'll like
application.
sit there and wait and go doink, doink, and it'll just knock the ones out that it doesn't like, and and they end up down in here. It's pretty cool. I like those. It just has too many perfect ones in a row. Of course, as soon as I say it's really cool to watch, it doesn't have any. Now it's good because it's going to have a couple holes. It's a pretty simple monkey, really. Awesome.
Good. So, what do you think is better, the full automated or the human?
I think a little of both. I think we say, here's an automated system, here's a human check.
First of all, human.
Yeah.
Then we have here a dynamic weight control. And this weight control is done non-stop measurement. After that, we have a
Weighing
second.
it as it's going by.
Yes,
It's weighing it as it's moving.
as it's moving. Dynamic. Non-stop. After that, length control and shape control also, and then visual inspection prior to putting the paper box.
So a human being in this instance, getting a
Yeah.
final visual, is everything good?
After everything, another human control just to guarantee the quality.
But there's an automated version of this too.
Yeah. And this big machine, we have full automated process for weighing, laser marking, packaging, and visual inspection with artificial visual inspection system.
So it's multi-camera, multi-angle.
Multi-camera and multi-angle in order to guarantee that no defect goes through. Why? Because we have a system that interprets it, that detects and takes the self-decision about what to do if one defect is detected. You know, that every defect the camera is able to detect and to separate after detection. So, then here we are putting the package on package. This is a packaging station.
Getting them all settled in there for final shipping.
Yeah.
And those are the ones that are heading to the house so that you can go have fun at the range.